Let's run through complete solutions to the next 4 calculator multiple choice questions from the released 2012 AP Calculus exam. This is problems 84 through 87, and as I said, they're calculator active, so make sure you have your calculator handy so you can follow along. Let's dive in. Okay, in this first multiple choice, number 84, we're given a rule for the derivative f prime, and we're asked to use that to work something out about the function f, namely the intervals on which f is concave down. We're going to use our calculator for this one, but let's see how that's going to work out for us. So we need to translate what it means for f to be concave down into an equivalent form. Because f being concave down tells me something about f prime and f double prime. Here in this problem, because I've been given something about f prime, I'm going to want to translate it into that form. So f being concave down tells me that f prime should be decreasing. That will detect that downward concavity of f for me. So all I have to do here is use my calculator to graph the rule for f prime and identify where it's decreasing. Simple. So let's pull up our calculator, bring up the y equals window, and I'll type my rule for f prime in. So it is e to the power of x to the 4 subtract 2x squared plus 1, and then I'm going to subtract 2. I could hit graph, but I'm going to go in and change my window, my viewing window, just a little bit so I don't get distracted. Whoops. Because I know that the x values I'm interested in are sandwiched between 1.5 plus or minus. So, okay, here is the graph of f prime, and I just want to identify what intervals f prime is decreasing on. So you can see it looks like I am decreasing starting from the left-hand side of the graph, so when x is negative 1.5, it looks like I am decreasing all the way down to x equals negative 1. Then I start increasing. I then start decreasing again at x equals 0. And I start decreasing all the way down to x equals 1. So what this graph looks like it's doing is something like this. Very quick sketch, but this downward behavior is changing at negative 1 and 0. So if I close my calculator, get back here, my graph y equals f prime of x is decreasing, then it starts increasing, and then f prime starts decreasing again. So you can see my intervals of decrease are negative 1.5 up to negative 1 and 0 up to 1. So that is where f is going to be concave down because f prime is decreasing. So the answer is choice D. Good job. Now in this next problem, 85, we actually don't need our calculator, which is always a nice position to be in, even on the calculator section. So we're asked, hey, here's a graph of f prime. I want you to tell me where the function f has a local maximum. So again, just like in that first problem, we need to translate that information that we're looking for about f into information about f prime. So to find a local maximum, that means that we need f prime, the first derivative, to change sign from positive to negative. And if we forget this, we can remind ourselves, because if f prime is positive, that means that the tangents are sloping upwards. And if we're changing from positive slope tangents to negative slope tangents, that is steering my graph of y equals f. And you can see how if the tangents steer from positive slope to negative slope, I'm going to get that local maximum that we're looking for. So remembering here that we are looking at the graph of f prime, where do we see f prime changing from positive values above the x-axis to negative values below the x-axis? Well, it's pretty clear, right? It happens at this value here. That's the only point on this graph where we move from values above the x-axis to values below the x-axis. So our answer here is x equals 1 is where f has that local maximum. That one was nice and quick. Okay, so I just said that one was nice and quick. This next one, number 86, is a little bit longer, a little bit more involved, but it's still not too bad. So let's take a look. So we're given some information about a function f, and we're asked to pick which of the following tables of values could possibly be tables of values for this function. So we need to somehow do a process of elimination, maybe say 4 of them won't work, the 5th one maybe could work. So let's unpack the information that we have here. So we're told that f prime is always positive. So that means that f, the function itself, will always be increasing. Okay, so that's a nice property to know about f, and we can use that already to rule out some of these tables. Because notice that my x values in every table are 4, 5, and 7. So as I go down my table, my x values are increasing, 4 to 5 to 7. So let's see what my f of x values are doing as x is increasing. Well, if f is supposed to be increasing, those values should be going up as well. So let's see. Here, -4 up to -3, that is good. -3 up to 0, yep, that is an increasing table of values for a function. So that is possible. Similarly, for option B, -4 increases to -2, which increases to 5, could be choice B. But you can see we get an issue with possibility C because -4 increases to 6, but then 6 drops back down to 3. So that function is not an increasing function, so it can't possibly be representing our increasing function. Similarly, for choice D, okay, we've got zeros at 4, 5, and 7. Okay, so that function is not increasing as we're moving to the right. To have that happen, we'd have to swing back down in between to get those 0 values, or be constantly 0, which again is not an increasing function. So we can't have choice D. But choice E is a valid choice because 0 is increasing to 4 and 4 is increasing to 6. So it's not bad. We're taking a little small observation about our function using its first derivative f prime, and we've already eliminated 2 of the possibilities. Haven't even used anything about this definite integral yet, but notice, because that definite integral is equal to 0, that forces this graph to have some portions above the x-axis contributing positive area to the definite integral, and some portions below the x-axis that will contribute negative area to the definite integral. So this observation tells me graph must lie above and below the x-axis. So let me show you with an example why that has to be the case. So if we look at answer choice E here, let's say we're going to draw a little quick sketch of what this graph might look like. So I have 4, 5, and 7 as my x inputs, and my points on my graph at x equals 4, the function takes the value 0, at x equals 5, it's taking the value 4, and at x equals 7, it's taking the value 6. Okay. But remember, this function has to be increasing. So I don't know exactly what it looks like, but it can't go down. Okay, the only way is up. So I'm going to start at this point and increase, not really sure what I'm doing, but something like that. So when I look at this definite integral that we know has to be 0, that's measuring the area under the graph. So this area under the graph, because the function must be increasing, okay, when I calculate that definite integral, it will be positive. In particular, it won't be 0. So answer choice E cannot be the correct answer using that definite integral information. For a similar reason, you can see that answer choice A isn't possible either. I'll quickly demonstrate that for you just by reusing this graph. Okay, if I erase a lot of what's going on here. This time my values are 4 is taking the value -4. Whoops. -4. When x is 5, we get -3. And when x is 7, we get 0. But again, it's that same fad because f has to be an increasing function. Don't know exactly what it's doing, but it has to look something like that. It can't ever turn around and go down. So I know the area under this curve has to look like this. It's entirely below the x-axis. So when I compute that area as a definite integral, it will be negative. So it can't be 0. That leaves just one answer choice, choice B. So if we're confident, we can just circle it and move on. If we're under time pressure on the exam, maybe that's what we'll do. But since I've got you here, let's actually explore and dig in and see why it is actually a valid option. It does allow for the kinds of behaviors that we are seeing for this function, f. Okay, notice because the coordinates, the f values, are sometimes positive, sometimes negative, I'm able to have area positive above the x-axis and negative below the x-axis. So when x is 4, I get -4. When x is 5, I get -2. And when x is 7, I'm jumping all the way up to x equals 5 up here. So again, I don't know exactly what this graph looks like, but it's going to look something like this because it has to be an increasing function. So when I compute the definite integral, I get this portion below the x-axis that is going to be negative, and I get this portion above the x-axis that is going to be positive, and that together, if it's balanced just right, can sum to give me a 0 for the definite integral. So our answer choice here is B. Okay, last problem of the video, number 87. Again, we're actually not going to need our calculator for this one. I'm not sure how we would use our calculator for this one because we don't have anything to type in there. Again, we're going to be given some information about, in this case, the function. We want to again know where it's concave down. We need to translate that into information about what we know. So, this function being concave down, well, I have the graph of f double prime. So I need to translate downward concavity into information about f double prime. Well, being concave down means that f double prime is supposed to be negative. So I just need to look at this graph of f double prime and see where it is negative, see where it lies below the x-axis. That is pretty straightforward. It certainly lies below the x-axis there, and also here in this region. So if I look at the x values that make that happen, okay, I have x lying between -2 and 1. And then over here in this region, x is lying between 1 and 3. That happens in answer choice E. That one was also pretty quick. Okay, how did you get on with those 4 problems? Some of them were pretty rapid fire. That table one was a little bit more involved. Let me know how you got on. Which did you find tricky? Which did you find more straightforward? I'd love to hear from you. If you were a little bit unsure on what was going on with our calculator, please do check out my calculator skills video where I run through the 4 calculator skills that come up every single year on the AP Calculus exam. If you know how to do those 4 things on your calculator, you are going to be in really good shape. Apart from that, I'll also put a link to the full multiple choice playlist from this 2012 exam so that you can run through them in order. Apart from that, I will just say see you in the next video. Bye for now.